Welcome to New Frontiers, a show that's all about exploring the science, discovery, and innovation happening at the University of Arizona. I'm your host, Erika Hamden, and for this episode, we're going to learn all about 3 new NASA missions that the U of A is involved in. Get ready to explore Arctic glaciers, Jupiter's icy moon Europa, and what's next for the Osiris-Rex spacecraft. For our first story, I'm heading to Marana Airport to meet up with a colleague who also happens to be a pilot. I'll see you there. As a pilot myself, I'm particularly excited for our first story. It involves Jack Holt, a professor at the Lunar and Planetary lab, who uses low-flying aircraft to study glaciers in the Arctic. He gets to fly over some of the most remote and spectacular landscapes on Earth, landscapes that are only visible from the air. We had an incredible opportunity to send our cameras with him on his last flight in Alaska, and the footage is something you have to see to believe. So check it out, and we'll talk with Jack afterward.
It's clear from the data, the global data, that things are changing rapidly. You know, over the past 10 years, flying over specific glaciers in Alaska, I've seen the change myself. We see big lakes starting to form in front of glaciers as the glaciers retreat, icebergs calving in, giant lakes with icebergs that didn't exist like 5 years ago. That's the sign that things are changing extremely rapidly, and we need to study them now. Snow for Flow is a NASA project under its Earth Ventures suborbital program, and it's a very large airborne campaign to study glaciers in the Arctic. We're going to be using multiple instruments on an airplane to measure snow depth and ice thickness, and use that to better constrain their mass balance to project their behavior in the future. Glaciers are often cited as a big source of uncertainty in the climate models that project what's going to happen in the future. And so we're zooming in on the glaciers that are changing the most rapidly and that we understand the least. We currently have no sensors in space that can do these types of measurements, but you can do it from airplanes. We've established the techniques over the last several decades doing airborne surveys in Antarctica and Greenland and in Alaska, where I've done a lot of my work. So we're at Marana Regional Airport, just northwest of Tucson. It's a great little community out here. Pilots who work on their planes, build their own planes, share tools. I keep my plane here, in the winter, and I often will be just doing routine maintenance on my plane, changing the oil, doing the brakes, going through an entire annual inspection where we open it up completely. We take out the seats. And I love learning all about my plane. So it's a little odd being in Arizona and studying glaciers, but we can't just live in a microcosm here in Arizona and think we can solve all of our issues here alone. We need to look elsewhere, like to the global picture, because climate is a global process.
So we know why that's there? My guess is maybe.
So when I'm back here at University of Arizona, I'm working with my students a lot, analyzing data from the field campaigns.
And kind of in the airborne data and even in the 2023 surface data.
We also work on the instrumentation. We've developed radars to do the types of measurements we need. Hey, Doug. I developed this radar over several years, and it goes into this antenna that's very, 30 meters long, that's towed behind the airplane. So in flight, we take off, get to our flight altitude, and then we just like spool it out a hole in the bottom of the plane and with a little drogue in the back. So this project has involved a lot of really great scientists, and Ali Barangi is one of those people. He brings expertise that we really need to tie our measurements into a bigger picture.
Satellite data from, for example, GPM type of observation.
I do a lot of precipitation estimation from satellite data and using satellite to study entire water cycle in general, but more focused on the precipitation side of that. And in recent years, I'm more interested in looking at higher latitudes, especially because of the tight connection to climate change and how rapidly they're evolving.
Prioritize where we need to fly first.
This particular mission, Snow for Flow, can provide us with unprecedented data set that we never had.
Areas of convergence
and then we also have people using completely different types of measurements, including Chris Herrig in the Department of Geosciences. And he uses primarily gravity data to look at changes in ice volume through different seasons.
From my perspective, we're a little more fuzzy on what's... So there's a couple satellite missions which measure Earth's gravity field, and they give us a really great but also broad picture of mass changing on Earth's surface. And the Snow for Flow is really a complementary kind of project to that, where it's focused on the small scales. It's focused on like individual glaciers.
Okay, so we've got these seasonal snow layers, and
we start adding a lot more detail into our modeling, and that hopefully results in a much more accurate kind of picture of how much ice is being lost and affecting sea level rise.
Pretty cool result, being able to not only map the previous season's snow accumulation. We've learned a great deal from studying certain glaciers in the past 10 years. In Alaska, one in particular is called Malaspina Glacier. Over about a 5-year period, we noticed giant pits sinking into the ground, trees falling in, and we realized there was a lot of ice under the ground in front of the glacier, and there were connections starting to be made between the ocean and the glacier. Once that happens, you get rapid melting, and it's very difficult to stop. When you see them year after year and you see these big changes, yeah, it kind of hits you like, wow, these are going away fast, and it does convey a sense of urgency to do this kind of work. Well, sometimes when I've been in Alaska flying, in the survey plane out over the glaciers, I just think, wow, I can't believe this is my job. I love being out there, just out flying over these remote places, seeing the big picture. And that's the only way to do it. There's really no other way to get these measurements and gain the knowledge that we want to gain. All of this information feeds into, hopefully, us improving as a society in terms of taking care of our environment, managing our resources, making a difference while we can. That's my goal, is to help make it a better place, for our kids and future generations.
So, here with Jack Holt, and this is the plane that flew us to get that incredible footage in Alaska, right?
That's right, and I flew it back to Arizona in October.
How many hours of actual flight time is that?
About 25 hours of flight time.
That's much slower than a commercial airplane.
Certainly is, but you get to see a lot along the way. Camped in some really special places.
How old is the plane?
Well, it's a 1964.
It's older than me.
Yeah,
Can we take a
1
look
year
on?
older than me.
Can we take a look on the inside?
Absolutely.
All right. Ooh. All right. Turn it on.
Sure. Check out the panel. Yeah,
Okay.
flip on the master.
Master on.
This is the new panel that I installed last year.
So you did that yourself?
Yeah.
It's very instrument person to do the wiring yourself.
Yeah, kind of harken back to my
That's like
engineering.
what I would do.
Yeah, it's great to have all the modern avionics.
Yeah. Well, this was really cool. Next time I want to go up.
Absolutely. Let's do it.
All right, so turn off.
Yeah, sure, Dan.
All right, avionics master. And all right. So all this stuff about glaciers is making me think of our next story, which is about a different icy location in the solar system, Jupiter's moon Europa. And you have some colleagues at the Lunar and Planetary Lab that are working on the Europa Clipper mission, right?
That's right, I do.
It's gonna be like such a fantastic mission when it gets there.
It really is. I can't wait to see the results from that.
So Europa Clipper is NASA's next big exploratory mission to another world. Previous missions to Jupiter have indicated there's likely a massive liquid ocean underneath Europa's icy crust, which makes it the next best place in the solar system to search for life. The University of Arizona is involved in 2 of Clipper's main instruments, which, taken together, will allow us to peer above and below Europa's crust to finally discover if there's really alien life there.
Curious at beauty, at leaf and blossom, at grief and pleasure, sun and shadow. And it is not darkness that unites us, not the cold distance of space, but the offering of water. Each drop of rain, each rivulet, each pulse, each vein. Oh, second moon, we too are made of water, of vast and beckoning seas. We too are made of wonders, of great and ordinary loves, of small invisible worlds, of a need to call out through the dark.
8, 7, 6, 5, 4, 3, 2, 1, ignition, and liftoff. Liftoff of Falcon Heavy with Europa Clipper, unveiling the mysteries of an enormous ocean lurking beneath the icy crust of Jupiter's moon, Europa. Rocket beginning to roll.
Europa Clipper is a NASA mission dedicated to studying Europa, especially to understand the habitability of Europa. We're pretty sure that there's a liquid ocean inside Europa beneath an ice shell that's anywhere from 10 to 50 kilometers thick. It is, in the view of some, the most likely place to find extant life. Think about the black smokers, the sub-sea floor life on Earth. If there's something like that on the floor of Europa, then that could really be teeming with life. And then, what does that mean for life elsewhere in our galaxy?
Via the video, we can see that Clipper has successfully separated. Please say goodbye to Clipper on its way to Europa.
So I'm a planetary scientist, mainly a planetary geologist, and I've worked on many spacecraft missions. I sometimes describe myself as a mission junkie. One mission I started working on right out of graduate school was the Galileo mission at Jupiter. Galileo mission showed that there's probably a subsurface ocean inside Europa, which is very interesting for habitability. Now with Europa Clipper, we're going to go back with a very large data return capability. Europa is one of 4 of the Galilean satellites discovered by Galileo himself back in 1610. 3 of these satellites have a very interesting orbital configuration around Jupiter, and this creates forced eccentricity of the orbits. And that means as you go around massive Jupiter, their shapes change. They swell and contract in shape, and this produces a tremendous amount of tidal heating. So Europa Clipper isn't formally looking for life. It's trying to understand Europa's habitability. So we want to know, is it currently active?
So on Europa Clipper, there's a number of instruments, many instruments, but the one that I work on is the Reason radar system. And the waves are so long, they can go into the subsurface and bounce off of things there. So for example, if there's layering in the subsurface, different density layers, or if there's water, like if you had kind of a reservoir of water sitting in the upper crust, those are all things that the radar wave will reflect off of. What we really want to learn for Europa is how the Europa system works. For example, what is the interior structure? Where is the ocean? Does the ocean interact with minerals or things that could be food for life, essentially? We don't really know for sure if there are plumes coming off that could bring some of this water up.
I'm involved with ICE, which stands for Europa Imaging System. This is a very innovative camera design. We need the wide-angle camera to cover a large area and to map stereo along a swath. Then we have a narrow-angle camera. It can collect enough signal while whizzing over the surface very fast to take very high-resolution images. And so we designed a new camera that we can run in either mode.
When we first arrive at Europa, I think all of us are just going to be immediately basically sitting there waiting to see what the first radargram is that we get back. There's just so many unknowns, so for me it's really like a sense of adventure going and seeing this new place that we really don't know very much about.
Hi, Sarah.
Hi, Alfred.
What have you got that's fantastic?
Well,
here at the University of Arizona, Sarah Sutton is working with me on ICE in her digital train model production lab.
With the Europa images from ICE. In my lab, which is a photogrammetry lab, we make stereo models, digital stereo models of topography of planetary surfaces.
Yep, this will be great data. We want to find future landing sites too.
So when we take stereo images, which we will be doing with ICE, you can look at them in 3D in a special monitor, and it's like you're there.
And look at surprising terrains, which I'm sure we'll see.
I am interested as a geologist in looking for if we can observe active processes on the surface during our mission. What we already know we will see are icy ridges, icy bands, plates that look a lot like icebergs and ice plates on Earth, chaos regions, like where it looks really broken up. I think getting at those questions is going to be really fascinating.
Exploration itself, it has great value. It's fundamental research. We can't predict what in the future this will lead to, but we can look back, and fundamental research has led to all of the advancements of the 20th and 21st centuries.
The sense of adventure really does drive me to do this spacecraft mission work. There's really this sense that we could go there and see something totally weird. For me, that's really the motivation to keep doing it.
We are creatures of constant awe.
Another aspect of this is appreciating life on Earth.
There are mysteries below our sky.
Life is very rare, especially advanced life like ours, so it makes us appreciate and hopefully do a better job of managing Spaceship Earth.
And it is not darkness that unites us.
I'm back at the University of Arizona with Dr. Sarah Sutton. So tell me about where we are.
This is one of the planetary photogrammetry labs here at the Lunar and Planetary Lab. What we do here is we take 2 stereo images of planetary surfaces, and we build 3D topographic models of them. And so when you look at it with these special glasses, you can see it in 3D in this monitor.
Okay, so let's take a look.
Sure. What we're looking at here is a high-rise stereo pair of Mars, a crater on Mars.
Wow.
And so we can see it in 3D on the monitor, and we can use this special mouse to zoom in.
This is a great crater.
It's very interesting.
An amazing amount of detail.
Yeah.
Like, I can't believe that we can
it's
do this. It's another planet.
It's like the next best thing to being there. It's really
it would be
cool.
pretty cool to be there. But that's amazing. And there's like a crack there. Wow.
And then those boulders
Yeah.
are probably a few meters wide.
Wow. What else can we look at with this?
So we also make topography models of the moon, and we have also done work on Bennu with Osiris-Rex data.
Can we take a look at that? Bennu is the University of Arizona's favorite asteroid.
Yep.
It really is just like a collection of rocks.
It's a lot of boulders.
Like loosely held together.
Yeah.
Wow. Are you gonna use something like this with Europa when Europa Clipper gets there?
Yeah, so the Europa imaging system, or ICE, is the cameras on the Europa Clipper. And there's a wide angle camera and a narrow angle camera.
Okay.
Both will be able to take stereo images.
Like these, to make these types of visualizations.
It's going to be unprecedented views of the surface of Europa. I'm very excited.
Wow, well, I cannot wait to see images like this from Europa Clipper. That's gonna be incredible.
Me too.
So these images of the asteroid Bennu came from the Osiris-Rex spacecraft, which is also run by the University of Arizona. That mission recently reached a dramatic conclusion after a 7-year journey to rendezvous with the asteroid, descend to its surface to collect a sample, and then successfully return that sample back to Earth for scientific study. Now that the mission has ended, the spacecraft has a new mission to a new asteroid, and it has a new principal investigator, Danny Della Giustina, who is continuing a long University of Arizona tradition of handing the baton to the next generation.
Do you see yourself as a PI of a mission someday?
I won't discount anything.
In exactly 999 days from this moment, our launch window will open up and Osiris-Rex will be on his journey into the inner solar system to asteroid Bennu.
So I was first involved in the Osiris family as an undergraduate student here at the University of Arizona. But when the opportunity did develop to join the Osiris-Rex team as a junior image processing scientist, I jumped on it.
Status check. Go Atlas.
Go Centaur.
Go Osiris-Rex.
And so I became the lead image processing scientist for the mission. My name is Danny Della Giustina, and I'm the lead image processing scientist for the Osiris-Rex mission. It is my first time watching the launch of a NASA mission, so I am thrilled. I'm super excited.
And liftoff of Osiris-Rex, its 7-year mission to boldly go to the asteroid Bennu and back.
It was a big learning experience for me, but also a lot of fun, and really solidified that this is something that I want to do.
OREX MSA on OREX Op. OREX has descended below the 5-meter mark. The hazard map is go for tag.
And we have touchdown!
And then shortly after we departed Bennu, I stepped into the role as Deputy Principal Investigator. Now getting to lead as Principal Investigator the next phase of this Osiris journey with Osiris-Apex is really exciting. So Osiris-Apex is an extended mission that will follow on the heels of the Osiris-Rex NASA mission. After the sample is brought back and dropped off on Earth, the spacecraft doesn't really have a purpose. And so last year we proposed to NASA to continue to use the spacecraft, send it to a new object, an asteroid called Apophis, which it will rendezvous with in 2029. And we're changing our name from Osiris-Rex, which stood for Origins, Spectral Interpretation, Resource Identification, Security, Regolith Explorer, to Osiris-Apex, where Apex stands for the Apophis Explorer. Asteroid Apophis is a pretty infamous object because when it was discovered in 2004, there was an initial scare that it might impact the Earth in 2029. It's a very close approaching asteroid, and later observations of Apophis that same year indicated no, it's not going to impact the Earth in 2029. However, it will get within 1/10 of the distance between the Earth and the Moon, and we'll be able to see it with the naked eye here on Earth. It represents this class of potentially hazardous asteroids well in a couple key ways, and we think that during the 2029 close encounter with our own planet, where it gets this close, that it might get disturbed by that gravitational tug that our own planet is exerting on it. And so we're really excited to send a spacecraft there to observe the effects of this, and also just to characterize it as an analog for other potentially hazardous objects. But we are also doing a couple of sporty things with the spacecraft. So at Apophis, we plan to get really close, turn our thrusters up, move a lot of material on the surface, and then back away and take another look. We want to see what its subsurface looks like, and we're excited for this spacecraft maneuver that is going to help us do that. It's a pretty incredible privilege to wake up every day and explore space. We're taking images often of an object that nobody's ever seen before, or at scales that are unprecedented. And so I am the first human in existence to witness something. And that is just nuts and so cool. And I never get tired of it. And that's why I'm a scientist, because I am just addicted to that feeling. And I am so excited that I can continue to do this type of exploration at Apophis.
Thanks for joining me on yet another journey across the solar system on this all-new episode of New Frontiers. I'm Erika Hamden. I'll see you next time. Make sure to stay tuned for future episodes where we'll explore more of the incredible innovation happening here at the University of Arizona. And if you want to know what's happening with me, follow my Instagram @Erika Hamden.